concept is true. So you would pick your own matrix, you would find the transpose, you take a transpose again, you would demonstrate that that concept was true. Okay, so, okay. I think we had another question in the back, yes.
I got a couple.
Uh-huh.
Okay, so I'm aware that the practice exam is not be the same thing as the original exam. That part's true.
Yeah, it will be a completely different exam.
But let's just say you take the practice exam the second time. Are the answers gonna be there, or the answers gonna be changed a bit?
I'm sorry, I couldn't hear the last part.
On the practice exams, on the same, it's gonna be the same questions, but are the answers gonna be different, or they're gonna be changed?
No, they're going to be different questions.
Okay, good to know that part.
Yeah.
And where exactly do we drop off the homework? Is it gonna be like a attached to a canvas that there's gonna be a drop off with all your problems that you did?
Well, I'm hoping that you're taking notes in class and that you're reviewing the recordings if you need to. So you have those two ways. The other good way to study is by looking at the study guide.
I mean, like for the exam, once you write down your problems and how you solve it, where do we turn it in?
You don't, because you're submitting it online. So there's no drop off of papers.
I think it just means like you just have to show the paper on the camera. Yeah, so just
Yeah,
show.
you have to show the pieces of paper to the camera, but you're also submitting those same pages online.
You'll scan the paper and you'll make it like a PDF.
So,
Really?
yes, so everything's gonna be turned in online. So that's something that you wanna make sure that you have looked through this, like with all these different instructions. So if you'll notice here with the scrap work, it kind of tells you about it in this format page. So if you haven't gone through these things that I put in the exam 1 module, you're gonna wanna make sure you're fully aware of all these. But your scrap work is to be submitted immediately following the exam. So once you are done with the exam, so on the exam at the beginning, you'll show your blank pieces of paper front and back. At the end of the exam, you'll show those same 5 pieces of paper front and back. The exam will close. Then at that point, you would want to go ahead and take some pictures of your scrap work, and then you will go ahead and you will submit them to Canvas as well. So for instance, you'll notice that here is your exam 1 scrap work assignment, and that's where you're going to submit your scrap work immediately following the exam. So I'm not making you do it during the exam, before the exam time runs out, because I know a lot of you get stressed out and you want to have the most time possible to work on your problems, but you do need to turn this in, your scrap work in, immediately following the end of the exam. So after the exam ends, in that next 10 minutes, you need to go through, take your pictures of your scrap work, and then you're going to go ahead and submit them and upload them to this Canvas assignment. So do make sure that you know how to do that. You want to make sure that you have something that you can easily know how to upload JPEG images. Some people prefer to even use some sort of program like Microsoft Lens or Cam Scanner. That makes it very easy to kind of submit all your work at once as a PDF. So that'll be something that you want to do with your practice exam. Like once you finish working on the practice exam, practice taking pictures of it, how you're going to go ahead and submit that. This is something that you're going to have to do in the workforce anyway, so I'm trying to get you some practice. You're going to need to be able to convert a lot of different documents to PDFs, or there might be something out in the field that you might need to take images of and create and put as part of a document. So this will be good practice. So I encourage you to make sure you have looked through all of this stuff that I have information on. The other thing too is that for your exam, there is no access code. I did not set one up. If you run into any problems with it asking you for some sort of access code, that indicates that there's an issue on your end. It indicates that either you're having some issues with AutoLock setup, it indicates maybe your internet strength is not sufficient. It might indicate that maybe you haven't cleared your history or your browser cache, or have have something else that's preventing you from moving on to the exam. Because there should be no access code at all. Your exam should automatically move past that page. So just wanted you to be aware of that. So that's why I say use that practice exam. Make sure you work out any issues with your laptops. I'm not going to be able to help you troubleshoot with HonorLock during the exam. So if you do encounter a problem, make sure that you immediately contact HonorLock so that they can help you. They get paid big money to be of service for this proctoring system. So they're like the best people to immediately get in contact with it. So do make sure you know how to contact them just in case. So if something pops up, do contact HonorLock technical support. Great, let's see if we have any questions on it. Any questions? I'll stop there again. Yes, sir. It'll mark you, yes. So I'm trying to mimic everything so that you have a full exposure to what your exam experience will be. So all the settings on the practice exam are exactly the same as the real exam. So you want to treat it as such so that you're fully prepared for the real exam. So I would also, for the practice exam, I would recommend that you don't just click through it and end it. I would recommend that you stay on it for a while so that you can make sure that your camera really is working, that your internet strength is sufficient, nothing weird happens. So you want to have a substantial amount of time where you let that practice exam run just to make sure. Sometimes, for whatever reason, people do stuff during the exam that they don't realize. And then they get flagged, so using that practice exam is going to really, really help you. Okay. So, let's make sure I covered everything. Okay. So like I said, don't panic if you don't see the exam until Thursday. Okay? But it will pop up in your exam 1 module. So this is the one to know. Is your exam 1 module, it's got your practice exam, it's going to have your real exam on the day of. It's going to have your scrapwork assignment where you will immediately turn in your scrapwork. So make sure you take note of the time. You do need to turn in your scrapwork immediately following the exam. There is a strict time limit on this because your scrapwork needs to exactly match what you showed in the camera, and it needs to not contain any extra work. Have people try to fit in extra stuff. And so you do need to turn that in immediately. So if you don't meet that cutoff, there will be a grade deduction. So make sure you get that scrapwork in.
Is there like a time limit to get that work turned in? Because I know
Yes.
it's like a PDF, so like
Yes.
you have to convert all the pictures into PDFs and stuff.
Yeah. Yeah.
So how long would you say the time limit is?
You get 10 minutes.
10 minutes?
Like,
So it shouldn't take too long if you practice, because I've done this many times myself. You're just basically taking your pictures, and then if you use those particular apps, it's really, really quick. You'll want to also make sure that you use the practice exam to practice that. So really treat it like a real exam, and this is something that you're going to want to make sure you know how to do.
oh, yeah.
Or JPEG images, yeah. So you can either turn into PDF or JPEG images, but you should easily be able to do those with your phone. That's why I would highly recommend that you have the Canvas app on your phone. That way you can just submit things right from your phone. You don't have to do all this lengthy transfer business. So we all have to be very well versed in using our phone these gonna be the method that you need to use for the phone that you have. So, practice that real quick. Alright, the other important point is your exam will start at 2:30 p.m. and it will end at 3:45 p.m. So it's only the length of one class session. I would not torture you with a 2-hour exam. That's more like a final exam, right? So this is just an exam along the way during the semester, so it's only one class session. Also, I'm not going to make you take exams that are longer than the students in the other semesters. So that brings me to my point of what you do after the exam. So you're going to be taking it, it'll start at 2:30, it'll end at 3:45, so you have an hour and 15 minutes, unless you have SAS accommodations. So it's a final reminder for people who need SAS. Please make sure you've gotten in your accommodations to me. Those of you who have SAS will take the rest of the remaining class period to finish up your exams. For those of you who finish at 3:45, you'll have 10 minutes to turn in your scrapbook, so make sure you get that in by 3:55. Obviously, SAS students will be turning it in later after they're done. With the remainder of your class period, I totally get it if you want to relax and your brain is mush. So you can either take the rest of the class period to, do your own thing and, refresh yourself. If you're feeling particularly spunky and productive, you can actually choose to go ahead and reach out to your teams if you want to. And I will let that be your choice. And I wanted to let you know that what will happen, and let's check out our course schedule together. Okay. If you happen to notice here, your exam will be on Thursday, and then you will notice that on that following Tuesday, you have your first designated day where you get to work in teams. So you will get to choose a location of your choice, where you will get together with your team and you will automatically get started on your team projects. You will have a team assignment where you have to decide your team name and you have to do a fun team building activity together. You'll be talking about ideas of what you want to do for your project. You'll see some other instructions from me in Canvas so that you know what your team project's about. I'm not putting it in there now because I don't want to overwhelm you. I want you to just focus on your exam. But as soon as your exam is over, you'll want to start looking for those team assignments and instructions. So that Tuesday following your exam, you will get ready to rock and roll on that team project together. What you will also find is that underneath your modules, you will have a linear algebra application project module. And I've gone ahead and I have set all your teams. So we're going to go ahead and look at those today. So they are basically who you told me you wanted to work in a team of 5 with. There's only a couple exceptions. So team 2. Where's my team 2? Anybody in here? Okay. Team 2, please welcome Jonathan to your team. So you'll want to reach out to Jonathan. He was a late add, so you'll want to make sure that you have introduced yourself and you add him to any communication platforms. Let's see who else had some additions. I think it was Team 9. Team 9, are you out there? Please welcome Joshua. Where's my Team 9? Alright, so please make sure you welcome Joshua. Make sure you contact the right one. There's a couple people that have the same names in this class, so you always want to check. That's why I get you to all to learn each other's last names, interview numbers, so you get the right one. Believe me, it avoids a lot of issues. So Team 9, Joshua G. I'll reach out to him. Team 10. Here is a team that you need to that is assembled from our late joining members. So, who recognizes their name for Team 10? Nobody in here? Oh, there must be, okay, that's right, there must all be online. Okay, so online folks, please make sure that you see yourself on the screen and you realize you have been put into a team. Let's see, is the scrapbook graded with the same weight as the exam? Yes, it is. It's put into your exam and individual work category, which is worth 60% in this course. So it's lumped into that category with your exam. So really, here's the deal. Like, I am really trying to help you out with your grade. If you turn in your scrapbook on time, you get extra points. So just turn it in. It's 3 points for turning it in. Okay, how should we format our answers in the text boxes for the exam? There are some fill-in-the-blank answers where you do definitely need to fill in the question answer. Like if I'm specifically asking for a number, I'm going to say fill in the blank. You need to put your number in there. If it's a question where you really need to use explanation of things or show a matrix or whatnot, I'll say, either you can put it in the text box or you can say see scrap paper and then show all your work on your scrap paper. So do make sure you look at those directions. Will the authentication process with Monologue take away from the amount of time you have to take the exam? No, it should not. If you have everything set up correctly, then you should be able to get through it really quickly. That's what the practice exam is for. So please do it many, many times. You can just go through and like you're getting through. Like you have it authenticate, show your ID, boom, select your camera, you're good to go. The exam is designed to take only an hour, so that extra 15 minutes is for all the analog stuff. So you have only 10 questions, so really, there's extra time already budgeted in for your analog process. Okay, I think that answered all the questions. Alright, yeah, so we know what's happening. We have our exam on Thursday, then Tuesday we just have fun with our teams, get to reconnect, see what's going on. Hopefully you'll share some summer plans together. Let's see. I think that was, alright, any last questions? So I won't bog you down with too much team stuff because I want you to pay attention to your exam stuff, but then after your exam, look out for campus announcements. Yes. Okay. Oh, and I love that question because guess what is also good about the practice exam? It shows you all the stuff you're going to be given on the exam. So there's no need for memorization, but I am expecting you to understand the concepts. So the practice exam will literally show you all that stuff.
Those were the same thing.
They're the same, yeah. Yeah, because as we go through each section, we're adding to those equivalent statements. So it's just building on the same list. Yeah, you don't need to memorize. But check out your practice exam so you know exactly what's provided to you on the exam and you can quickly get to the information you need. Please don't let the exam come and you haven't done the practice exam. It's really, really important that you do it. Because you're not allowed lecture notes, you're not allowed any kind of materials, right? Everything's given on the exam. So, let's see. Yes, the theorems at the end, yes, they are also given on the real exam. You're exactly right. So all the stuff provided on the practice exam will be provided on the real exam. I don't want you to have a stress.
Are you saying that it's like a formula sheet that's to be printed on the exam?
Yes, I'm already giving you all the stuff you need.
Okay.
So this should really, like, you should breathe a sigh of relief. All this cool stuff from the chapter you're already given. I'm just asking you, please make sure you review the content, you understand what all these things mean. You familiarize yourself with the content that I'm giving you, that you review all the different problems that we go through. So so that you are ready to solve them. So there should be plenty of cubes for you. Let's see. Okay. So with that being said, let us go ahead and we will jump to some problems now. And get into it. Okay. Alright, so we left off with section 1.3. You all have, I hope you all have not procrastinated and you kept up with your content videos, that you have reviewed the sections, all that kind of good stuff. And it's already June, oh my goodness. And you'll already be done with a third of the class so soon. So, you're gonna be zipping through this. I know, summer is so fast. Can I share you all a little bit of piece of advice? I hope you'll let me get on my soapbox one more time, but please don't take summer classes again. Does anybody know why I say that? Everybody's looking, okay. Summer classes are something that you don't actually have to do in the summer, because if you take them during the normal year, you can always get a waiver at the end of your degree to waive the requirement for summer classes. The other thing too is your summer should be dedicated to getting work experience. So I don't want to see you guys spending any more summers on your education. You've got to get out there working. Because that's going to be the single most important thing for you getting employed after graduation with that work experience. Employers are extremely greedy. They want people who already have experience, unfortunately. So you got to get it before you graduate. So be focusing on your internships, your co-ops, all those things in your future summers. Please, please, please. If you need any help with that, you know where to find me. I can hopefully point you in the right direction, or at least give you some worthwhile advice. That being said, we need to go over, hopefully you are familiar, but just to make sure, we need to go over a couple ways of doing multiplication for our matrices. Now, adding and subtracting, what's our rule for adding and subtracting matrices?
Same size.
Ooh, good
Same
job,
size.
same size. So when we report the size of a matrix, how do we report it? Row by column, you got it. Alright, does anybody remember that cool little trick for determining whether or not you can multiply matrices? Oh yeah, those insides gotta match. Because what did I say? What's a really big thing I said about matrix multiplication?
Order matters.
Oh, you got it, yes. Order matters. For sure. Okay. Here we go. Let's look at a couple of matrices and make sure that we know our different ways of multiplying matrices. Alright, so I think you all should be able to see this particularly. Go ahead and okay. Let us say that A equals 4, -3 to -1. And let's say B equals 0, 1, 2, let's see, -2, 3, 1. Okay. Can we multiply these? Well, if we look at A, what do we have for A?
2 by 2?
Yeah, we got a 2 by 2. And if we were to multiply that times B, keeping that order, and we say, what is B here? What's our dimensions of B?
2.
Yeah, we got
2 by 3.
Yeah, we got 2 by 3 exactly. Can we do it? Well, we look at those inside numbers.
Yes.
We go, yes, we can do it. What would our dimensions of our product be if we do it in this order, A, B?
2 times 3?
Yeah, we get a 2 by 3. We'll be looking at these outside numbers. Let's see here. Can we by 2, can we do BA?
No.
Ooh, look at this. Not gonna happen, so it's gonna be inconsistent, we can't do it. So this would be a big fat no. So order matters, so your product, if you do it in a different order, it's possibly be inconsistent. So we wanna pay attention to that particular technique. But let's go ahead and look at our matrices, and we're gonna go ahead and we're gonna multiply them together. So if we go ahead, I'll go ahead and write it one more time. A is 4, -3, 2, -1. E equals 0, 2, -2, 1. Alright, does anybody know, has anybody made sure that they read and they know the different ways that you can multiply these matrices? So there's 2 that are kind of covered in the text.
Is it the partition one, like partition to like column row, and then you do row column like how many times?
Yeah.
I don't know the names of those.
Yeah, so we're gonna go over 2 of these. We're gonna go over row, column, and we're also gonna go over column, row. Alright, so the first one we're gonna look at is going to be column row. So we are going to, I'm gonna go ahead and use highlighters. Online folks, I will try to monitor chat, but if I can't see it, make sure you call out. Okay, so column row. We are gonna go ahead and pick the first column of our first matrix, and then we're gonna pick the first row of our second matrix. So we're gonna go ahead and write that out. So we would have 4, 2 times 0, 1, 2. And then as you can guess, we're gonna go ahead and add that 2 then, and we're gonna look at our next column. So we look at our second column of our first matrix, and then we're gonna look at our second row of our second matrix. And so then we would be doing -3, 1 times, who can tell me what the next one, what do I fill in? Yeah, -2, 3, 1. Okay, so this would be the column row method. So as you can see, we're starting off with the columns first, in order, and then multiplying them by the row, the other matrix. Okay, so then this first multiplication, here we're just gonna go ahead and we multiply 4, 2 times 0 in that first one. We're gonna get a product of 0, 0. Then we do that column matrix 4, 2 times the 1. What do you think we get? 4, 2. And then we do that column matrix 4, 2 times that last 2. What do we get? 8, 4. Alright, so that's our first term. Then we're gonna do that same thing with our next one. And then we're gonna get, what do you think our first column's gonna be now? We saw it follow that same pattern. Oh yeah, we're gonna get 6 and then what? Oh, there we go. 6 and 2. Okay, then we get -9 and -3. And then what's our last one gonna be? This one's easy. -3 and -1. So you see what I did there? Now we're just gonna go ahead and add these together, and what do we get? We get 6, 2, -5, -1, 5. What's our last one? 3. We can add those together since they're the same size. Okay. That is going to be your column row technique. So if that's easier for you to visualize and go through and do, by all means go ahead and do it. The next one is our row column method. I'll have to grab my matrices again. So A equals 4, -3, 2, what do you think we're gonna go and do now to get our next entry along that first row? Well, we're gonna repeat that pattern, I'll use a different color. So we're gonna go across that first row. What column do you think we're gonna choose now? Yeah, now we're gonna go down that second column. Oh my goodness. So now what do we get for that entry? Okay, now we're gonna get 4 times 1 plus, can anybody guess? Yeah, we got negative 3 times 3. Oh boy. Alright, we got one more row to get through. Okay, let's choose a different color here. We're gonna go down that first row again for the first matrix. Then we're gonna go down that third column of our second matrix. And now, what do we got? We've got 4 times 2 plus negative 3 times 1. So what do you think we're gonna do now? We keep following this pattern. Yeah, now we gotta do all this stuff for the second row of that first matrix. So we will go ahead and try to come up with even some more colors. Let's see what happens. Alright, so here's our second row. What are we gonna do? We're gonna go our second row and then down our first column. Oh my goodness. Alright, so we got 2 times 0 plus negative 1 times negative 2. Alright, gotta go grab another color. Alright, let's try this one. Alright, so we're gonna do that first row. Now we gotta go down our second column. Alright, so what we got? 2 times 1 plus negative 1 times 3. Oh my gosh. Okay. Another color. So as you can see, you might determine that your column row method might be the faster one for you all to visualize and do. But if you don't want to, you can do this one as well. Okay, so we got one more color pick. We go that second row and then now down that third column. Alright. Oh goodness. Are we done? What do you think? How do we know we're done?
Because the size of the matrix is the
Yeah.
same.
You got it. So we are done. Alright, so as you should be able to prove to yourself, you should get the same answer as the previous method. Okay, so if we go ahead, we have AB. What's in that first spot? You get 6, right? Here we get 2. What's our next value? Yeah, negative 5. Then what do we get? Negative 1, then what? Lo and behold, that's what we got before. Yes? So those are going to be your 2 methods for matrix multiplication. Okay. Just want to make sure that we went through that. Everybody has your 2 methods. Like I said, you pick which one you feel more comfortable with. Either way you pick, you should come out with the same answer. You want to use that same trick. Okay, let us move to our book here. Alright, so go ahead and go to the end of your section 1.4. We're going to start working those problems. And we'll look at that. Okay. You will want to make sure that you are work together. So for section 1.4, we have problems 2, 3, 5, 6, 7, and 8. So we'll try to see those. So for exercises 1 and 2, this is something that I would expect that would appear on the exam, something similar to this, if you had to verify that this was true. You might want to hone in on question number 2. So what are they trying to show you with this first one, part A? Let me just describe it. What are they trying to show?
The associativity of it and how it works with
Yeah. So we can move that scalar around in terms of order of multiplying times a matrix. What we can't rearrange though is what? The matrix order. Alright, so some things to kind of, these, you can obviously, you can work through, you can take these matrices and you can go ahead and follow through with each of these expressions, see if you get these to hold true or not, according to particular theorems. What does it mean in this second one? What is our order of operation here? So on this side, they're indicating that you would subtract C from B first, right? And then whatever that is, you would multiply with A, but with the order of A first. But you want to be able to describe that you could distribute it through like this. So work through these for sure. Alright, so let's go ahead and look at what we have next. We have number 3. This would be an interesting property. These are interesting. So these are other different properties that you will look at. And so do you know what this superscript T means? What is our transpose again? Yeah, you flip those rows and columns. So what is this first one telling you? Do you think? Yeah, you're doing a double flip, so what? You're then going back to your original matrix. Ooh, this one's interesting. So there's going to be some interesting things to note. So taking the product AB first, then taking the transpose. That's going to be a little bit different than if you take the transpose of each of the individual matrices. So you're going to want to pay attention to these different theorems. And this is something that I would definitely go through. What you might want to do in preparation for the exam is you would make up a matrix A and a matrix B. Ideally, if you're going to be doing verification, you might want to go ahead and choose matrices that are the same size to kind of make it easier on yourself. Because then, you know, you can multiply them, right? But you would want to make sure for yourself, okay, what happens when I multiply those two matrices together first? And then transpose, as opposed to if I reverse the order of those matrices, take the transpose, and then multiply them. So, think about that. Same thing with these on number 4. So these are kind of example ones that are going to follow. Let's go ahead and look at here it is. They're asking you, use theorem 1.4.5 to compute the inverse of the matrix. So how do we compute the inverse of a 2x2 matrix? What have we learned in this chapter? Oh yeah. What's the determinant? Oh, there we go. Okay. So what do? If you were to calculate this inverse, inverse is going to be the closest thing to matrix division. You don't really have matrix division. You can multiply matrices, but in some instances, we can do what's closest to division by finding an inverse. But it only applies to some matrices. So not all matrices can you find an inverse. How would I know if that matrix, there was no inverse? What would happen? Oh, good job. Yes, AB minus BC would be 0. Okay, so this one's really, really quick. These two, I would expect that you guys could do this in your head, maybe, potentially. Can you? Have you tested yourself? Because it go really fast in the exam, but you can. So you should be able to easily calculate AD minus BC, right? Then, all right, then you'd put, so hopefully you got 20. So you have 1 over 20, and then you said, what do we got to do in our entries? Yeah, so our A and D get flipped, and then we have negative B, negative C. All right, so you should get this as your inverse. So a lot of times with inverses, we get those nasty fractions for our entries. All right, next one. Let's see what we got. 6 and 7 and 8. Okay, 6 is the same thing. Let's do number 7. What do we immediately look at number 7 and see? 4. Yep. Okay, so that's really easy to calculate. So
You're done.
you're almost done there. So you just do what? Flip these two. All right. So you get 1 over 6, and you go ahead and do your calculations there. So let us go ahead. Let's see what other one I have you do for that section. Let's see if we got same thing. So this is something that you're going to want to make sure that you go ahead and practice. Okay. Make sure that for the 2 by 2, you easily can do this. You easily know what it means as well if you get 0 for your determinant. It meant what again? There's no inverse. Okay. And keep in mind, there is no true division of matrices, at least what you're learning in this course. So your inverse is going to be the closest thing that we get to it. So don't think of A to the negative 1, don't think of that as being the reciprocal of A, okay? You don't have reciprocals for matrices in the same way you might have for other forms of algebra. Okay, so that is...
I have a question, I'm sorry. Should we expect, is it really loud?
Yeah, go ahead, it's fine.
Should we expect to see problems with inverses with matrices bigger than 2 by 2? Okay, thank you.
So we're going to get into the next section where we are going to answer that, right? Okay, so we are now into section 1.5. Let's go ahead and check out those problems. Okay. Like I said, this is flipped classroom, so I do expect you to review those content videos to know, have an idea of what these different definitions mean before we come in here and we discuss these problems. So let's see if we can get through a couple of these for 1.5 before we go to break. What does it mean if you have an elementary matrix? Yes. Oh, good job. Only one operation. If you did more than one operation, is it an elementary matrix? No, it is not. So you have to be very careful with your definitions. What is an identity matrix? Yes.
It's a square matrix that's
That's in what?
reduced Rho.
Uh-huh. Which usually, if we were to describe it, what would that mean? Excellent. So make sure you listen to what your classmates just said. Please realize it is only refers to square matrices. Okay? Okay, so if we only did one operation, or for this problem number 1. Is this matrix elementary? What do you think for A? Okay, how do you know?
Times 5 log.
Okay, you guys agree? Yeah? Okay, let's check it out. Yes, it is an elementary matrix. You would be doing -5 times the first row and you'd add it to the second. So you have completed 1 elementary row operation. What do we think about B? Ooh. Why? I'm here to know. Anybody else? Let's check our tubes. So what do you think happened, maybe?
You have to do 2 operations. You have to get all of them. They swap the
Interesting.
rows.
So they swapped the rows and they did. Okay, so it is not an elementary matrix. They swapped the rows and then they did the -5 and added to the other. So that was 2 operations. Does not fit the definition. Ooh, what do you think is happening with C?
You gotta do multiple things.
Okay?
You gotta swap the rows at the bottom. And then you also have to do that one. You have a 1 side.
Yeah.
You have to get the one in the middle. You gotta do the one on top. So you got like 3 operations.
Oh, interesting. So too much stuff happening there. All right, what do we think about D? Do we know why?
Divide by 1, but you're still at 2.
Do we think more than 1 operation happened?
Yes.
Okay, let's see. Yep, not an elementary matrix. So what happened was, is they had to multiply the row by a scalar, and then they had to multiply another row by a scalar and add it to another. So 2 different operations going on there. Okay, let's see. Does everybody have any questions about that? Does everybody see what we're looking for? More than 1 operation had to happen for that matrix to result, so it didn't qualify as an elementary matrix. Okay, make sure you stop me anytime if something, all right, so let us look at, ooh, number 5. It says, all right, we've got an elementary matrix E, and we've got a matrix A given. And it says, identify the row operation corresponding to E, and then verify that the product EA results from applying that row operation to A. Ooh. Interesting. What do you think is our, it says identify the row operation corresponding to E. So what happened with E? Yeah. And then it's asking you, what would then that product EA result? What would be that resultant product then? You would
Oh,
do.
you don't have a
So if we know the operation that happened to E, we know that we swap the rows, yes? Then what operation do we need to do to form the product EA? So what do you think? We just swap the rows of A and that would be product EA? Alright, let's check it out. So you would interchange these 2 rows and that would be equivalent to product EA.
couldn't figure it out right away. We just like do the multiplication.
Good?
And then just say,
Yeah.
hey, this is that.
Yeah, you're exactly right. That's the way you can prove to yourself that that actually holds true. Like to show yourself that EA, that product actually equals that, test it yourself and multiply, go through either column row or row column operations and actually do the math and multiply out EA. You should end up with that matrix. So whenever you did to get the elementary matrix E, the product of EA is this doing that same thing to that matrix A. Does everybody see how that pattern is? That's really neat. Alright, so what do we think what do you think happened with B? Is everybody, so what do you think? You think we did negative 3 times the second row, added it to the third? I think Cody agrees with you. Online?
Am I going crazy? But if it's in the limit tree, then there should be a 0 there, so something else happened.
Where?
It should be 0, 0, 1. So when you did something over to, oh, we're going to take this down. I'm sorry, I said it right first.
Yeah, so
Yeah.
so let me just say, elementary matrices can sometimes trip you up. You have to make sure you got it. You might think more that is going on than really is, so you have to really think to yourself, did only one operation happen? So let's go ahead and see here. So if you added 3 times the second row to the third row, so that's what happened. We did negative 3 times the second row, added it to the third to get this elementary matrix. We went ahead and did that same thing to A, we get the product EA. So you have to multiply negative 3 all the way across this very long row of A, and then add it to the third row. So what do you think? You think they did that? So we get negative 3 times 1 plus 2, that gets you the negative 1. We get negative 3 times negative 3, that's 9 plus 0, that's 9 here. Negative 3 times negative 1 plus 1, you get the 4. So you guys see that pattern there? Negative 3 times 5 plus 3, you get the negative 12. Negative 3 times 3 plus negative 1, you get the negative 10. So keep that in mind. Okay, last one before we go to break. What do we think happened to this one? So what are we gonna do to A? Yeah. So we gotta do 4 times the bottom row added to the top. Alright, so hopefully you get something like this. You get 13 and 28 at the top. So hint, these might be things you might find on the exam. Hint, I might ask you, is this an elementary